geometry, mock tests, transformations, angles, and constructions. So the first question says we're trying to find a missing angle given parallel lines cut by a transversal. So it says lines M and N are parallel. So I'm going to draw a small little sketch of that. So they're parallel. So that means there's two lines going in the same direction, but they never meet. Okay. So this will be M and N. So a transversal cuts them, forming an alternate interior angles. So a transversal would be some type of diagonal looking line that's cutting it, okay, where there are going to be interior angles and exterior angles, okay. So in this case, the interior angle will be the inside of the transversal, and the exterior angle will be on the outside of the transversal, okay. So here would be an interior angle. Okay, and technically if you flip this upside down, this would also be an interior angle. So this will be interior, this will be the exterior. Alright, interior here, okay, interior here, right. Technically this would be exterior, okay. So when it says we're doing an alternate interior angle, we're saying that this angle is interior, this angle is interior, because they are opposite of one another but they're both interior. This would be an alternate interior angle, okay, because it has similar shapes even though they are not essentially on the same side, okay. They're on opposite side but they have similar measurements, so that means that they're alternate, okay. So with alternate interior angles, because they measure the same, we can say that each of them are going to be equal. So I'm going to say that 3x plus 10 is equal to 5x minus 26. So I'm going to try to get all the variables to the left. So I'm going to subtract 5x, and then subtract 10 so I can move the constants to the right. That will get cancelled. 3x minus 5x, negative 2x, is equal to 5x minus 5x cancels each other out. Negative 26 minus 10 is negative 36. Then I divide by negative 2, so x will be equal to 18. Okay, so that's what the value of x would be. But it says find the measure of each angle. So I'm trying to find the measure of this angle and this. So I would substitute 18 into each of these angles. So this first angle will be 3 parentheses 18 plus 10. 3 times 18 I believe is 46, I believe, no, 54, okay. So that would be 54 plus 10 is 64. So this first angle will be 64, and then the next angle I will do 5 parentheses 18 minus 26. 5 times 18 is 90. Alright, so 90 minus 26 would be 64 also. Okay, so which makes sense because again they are alternate interior angles, so that means this angle and this angle measure the exact same. So once we found the measurement of one angle, we'd have found the measurement of both. So this is 64, this is also 64. Okay, and if I wanted to find this angle would also be 64 because they are vertical angles. This angle would also be 64 because they're vertical angles, and then this angle right here would be 116 because it would be a 180 degrees. So this would be 116, the 116, 116, 116. Okay, but the answer for this would be 64. All right. So the next one says we're trying to identify the missing reason in a proof involving angles of a triangle. So the things you know about angles of a triangle are these things right here. So you know that the sum of all angles in a triangle, right, is equal to 180 degrees. Okay, so that's the main thing that you know when it comes on to triangles. So the sum of all angles is equal to 180. Okay, well that's actually what we see here. So it says angle A, B, and C. So if you have a triangle where we call it A, B, and C, so it says angle A plus angle B plus angle C is equal to 180, which does tells us essentially what is happening with that triangle sum. Alright, so what is the missing reason? Well, the reason for this would be not vertical angles are congruent, because vertical angles would be like angles like these. These would be vertical angles. But again, we don't have something cut by a transversal, so it's not going to be vertical angles. Okay, so triangle sum theorem, yep, it would be triangle sum theorem, because again, we're trying to find the sum of all of the angles. Okay, it wouldn't be a linear pair postulate, because a linear pair would be more associated with a with a transversal. Linear pair would be, for example, this is measure a line is measure 180 degrees. So the linear pair for this angle would be this angle right here, which would have been 116. Okay, those would have been linear pairs, the 64 and the 116. And then reflective property, well, we don't see anything that's even being reflected at all right? We don't see where it's crossing any type of y equal x or any type of axis, so the reflective property would not count for this one. So let's try the next one. So the next one says select the transformations that maintains congruence. Well, you need to remember that congruence means same. Okay, so which of the following transformations preserve both size and shape? So the only thing that doesn't preserve size, all right, is dilation. That's the only thing that doesn't preserve size. Because dilation means that you shrink it, all right. So dilation means that you're shrinking or enlarging. So it means shrink or enlarge. Okay. So if you shrink something, so if something gets smaller, all right, it has a smaller distance. If it makes it larger, it has a larger distance. So in that case, preserve means keep it the same. Preserve means keep it the same. Okay. So that means dilation is the only thing that doesn't keep the same. All right, because dilation shrinks. Okay, it makes it smaller or larger. So dilation will be out. Okay. So it says non-rigid reflections. Well, non-rigid reflection, we're going to come back to that one because that one is kind of close. Horizontal stretch is not going to be in, because again, if you stretch something, you're changing the distance. So if you have like a rubber band and you stretch the rubber band, the distance between where it was before is going to be larger. So this will be out. Translations and non-rigid reflections are the only ones, but non-rigid, so rigid motions are translations, reflections, and rotations. Non-rigid is dilation. So a non-rigid reflection would actually include a dilation. So this one would be out. So reflection maybe keep it in, but non-rigid means that you're doing some type of dilation. So that would mean that this is out. So translation is the only one. Okay. Okay, so then the next one. So the next one, we're trying to identify the graph of the following figure that undergoes the rigid transformation. So a triangle is has vertices. So vertices would be all the angles of the triangle. Okay. So we are going to draw a sketch. So we have a triangle where the angle at A will be at 1, 2. So 1 for the x, 2 for the y. 3, 4 be 3 for the x, 4 for the y. And 4, 1 will be 4 for the x, 1 for the y. Okay, so that triangle looks something like this. Okay, so I'm gonna put what those points are. So this point will be 1, 2. This point will be 3, 4, and this point will be 4, 1. So it says that we're reflecting it across the x-axis. So this is the x-axis. This is the y. So if we're reflecting it, that essentially means it keeps the same x value but a different y value, all right, because I'm reflecting it over this axis. So essentially all the x values are going to stay the same, but the y value is going to change, because here it's where it's positive. If I flip it down here, it's going to be negative. So the first point would be 1, negative 2, then 3, negative 4, then 4, negative 1. Okay, so again it would be 1, negative 2, then 3, negative 4. So this is 1, negative 2, 3, negative 4, and then this would be 4, negative 1. So 1, negative 2, 3, negative 4, and 4, negative 1. So that would be A. Okay, so let's try the next one. So the next one, again, we're going to try to evaluate, or rather, we're trying to identify points on a line segment given the weighted average. Okay, so weighted average is when we're evaluating ratios. So we have a graph, okay, of points. A, where it's 2, 6, so 2, 6 will be somewhere up here. And then 8, 12, 8, 12 will be somewhere, I'm going to put like maybe up here. It should be a lot higher, but somewhere there. Okay, so it says find the coordinates of P that divides AB in a ratio of 1 to 2. Okay, so essentially we have a line segment and we're cutting it in 1 part and 2 parts. So that means it has a total of 3 parts. Okay, because 1 and 2. So essentially what we're going to do is that we're going to look at the first point that we started with for X. That would be 2. You can use the formula. So if I want to kind of show you guys the formula again, The formula I think is x1 plus r1 over r1 plus r2 times x2 minus x1. Alright, and then you do it for y also, so it'll be y1 plus r1 over r1 plus r2 multiplied by y2 minus y1. Alright, you can try to use those formula for ratio, but I don't like using the formulas. I'm going to use what I'm used to using. So I start with 2, and then I look at the change between the x's. So it went from 2 to 8, so that means you added 6, and then we're doing it for 1 out of a total of 3 parts. So multiply by 1 out of 3. So we just go ahead and rewrite that 2. 3 times 1 is 3, or 6 times 1 is 6. 6 divided by 3 is 2. So that'll be plus 2 equal 4. Okay, so that'll be the x value that it's at. So the x value will be 4. So to find the y value, I started at 6. Then I went from 6 to 12. So that means I gained 6 again. And then I'm doing it in 1 part out of 3 parts. Okay, so this would be 6 plus 6 times 1 is 6. 6 divided by 3 is 2. So this would be 6 plus 2 is 8. So it would be 4, 8. Okay, so again guys, just like that. Alright, so let's try the next one. So we're trying to identify the relationship between figures on a graph using the perpendicular slope criteria. So it says line 1 has an equation y equal 2x plus 3. Line 2 passes through 0, 4 and 1, 2. Are the two lines parallel, perpendicular, or neither? Well, what you need to remember is that parallel means same slope. Okay. Perpendicular means opposite reciprocal. Alright, so opposite reciprocal. Okay. So we mainly need to focus on the slope. Well, because this is given in the form y equal mx plus b, we know that m represents the slope. Alright. So the slope for line 1, so line 1 slope is 2. Okay. So now I need to find line 2 slope. Okay. So I need to find line 2. So it says line 2 passes through this. Okay. So because it passes through these points, we can use the formula for rate of change to try to evaluate what the slope is. So the formula for rate of change is y2 minus y1 over x2 minus x1. So this would be your x1, y1, x2, y2. So I replace 2 for my y2 minus my y1 is 4 over my x2 is 1 minus my x1 is 0. 2 minus 4 is negative 2 over 1. So my slope before was 2, and then here I had a negative 2 for that slope. So that means I didn't do the negative reciprocal because I didn't do the reciprocal. The reciprocal of 2 is 1 over 2. So it was a negative, but it wasn't a negative reciprocal. So in this case, it would be neither. Alright. So let's try the next one. So the next one says we're identifying a step that complete the construction of the angle. Okay. So it says when constructing an angle, congruent to a given angle, what should be done after drawing the arc that intersect both rays of the given angle? So it says measure the original angle. So essentially, if we have a ray, so I think this is actually talking about an angle bisector. Alright, so we have a ray, and then we have another ray. We draw our arch, so then we need to go to the next arch and draw the intersecting bisecting arch. So it says measure of the original angle with a protractor, mark 2 intersection points. No, I think it's draw angle bisector. I think. Okay, I'm pretty sure. So in actuality, no. So this will be the last step because that's when we'll be drawing the bisector line. So we have to do these arches first before we draw the line. So no, it wouldn't be this one. It would actually be C. Draw the same arch at the new vertex, because this will be the new vertex that the line passes through. Alright, so that's actually what we will do next. Okay, so next one, we're trying to identify and describe the construction. So the construction begins with a line segment, then a circle is drawn using one end as the center and a segment as the radius. A second circle is drawn with the other end as the center and the same radius. The intersection of circles determines a new point. what is being constructed. So in this case, guys, we're trying to construct circles that have some type of equivalent intersecting point. Alright, so when we're doing that, what we're going to do is that we're going to evaluate that we're doing so let's actually draw it out, guys. So let's draw it out. So we're constructing a line segment, then a circle. So we have a line segment, and then a circle is drawn using one end as the center. So one end of the line segment is used as the center, and then the line segment as the radius. So here's the radius. Okay, the second circle is drawn with the other end point as a center. So the second circle is drawn with the other one as a center, and as the same radius. So the same radius. The intersections of the circle determine a new point. So where the circles intersect would be a new point. Okay, so yeah, where the intersect would be a new point. What is being constructed? This actually looks like a triangle. So because what we're going to do is that we're going to draw arch here. So we draw an arch from here with the same center point here, a little bit past the center. Draw an arch here. So I can actually show you with a compass. So what you'll be doing is that you're drawing an arch a little past the center point. So in reality, the arch would actually look more like this instead of what I did before. And then this arch, so same, yeah, center, would be right here. Okay, and then that would be that center point, that would be that bisector, and then you just connect this together. So we're trying to construct an equilateral because they have the same radius. So the distance between here and here and here and here are the same. So that means that this line and this line would also be the same. So that would be an equilateral triangle. Perpendicular bisector would have been more like if we had two line segments and you draw an arch here and an arch here. That would be more of the perpendicular bisector. Angle bisector we did for the previous problem, and copy of an angle would essentially be that we had an angle to start with, okay, and we didn't have any angles to start with. Okay, so question 9. So it says the original statement of two lines are parallel, then they never intersect. Which of the following is a contrapositive? So contrapositive means that you swap them and you do the not of each. So swap and the not. Okay, so if I swap them, I would essentially saying that I would say this part first. So this would be scenario A, this would be scenario B. So I would do scenario B and then scenario A and then the not of them. So it would be not B and then not A. Okay, so I would do not B. So instead of saying they never intersect, I'm gonna say that they intersect. Okay, and then not A, so they are not parallel. So two lines are not parallel. Alright, and not parallel doesn't always just automatically mean perpendicular, so it is not parallel. Okay, so so lines are not parallel, so no, they didn't swap here. Two intersecting lines and they are not parallel. So that would be this one. This one they swapped it, but it should have been, they didn't swap this one, sorry. And then this one they said the not, but they didn't swap anything. Okay, so let's look at the next one. So the next one says we're trying to solve problems involving parallel lines that cut by a transversal. So it says two parallel lines are cut by a transversal. One pair of the same side interior angles are this. Find x and both angle measures. So we have two parallel lines that are cut by a diagonal transversal, and then we're looking for same side interior. So same side interior will be, this is an interior angle, this is an interior angle on the same side. Alright, so with same side interior angles, you're gonna state that both angles are so if this is the same side, so this is the same as this right here. Okay, So we're going to say that they're equal to 180 because technically using alternate interior angles, this angle is the same as this angle right here. Okay, so these are the same, so these are equivalent. So that means this angle and this angle are the same. So if we add these two angles, we get a linear pair, and that will be 180. So that means that this angle, 2x plus 30, plus this angle, 3x minus 20, is equal to 180 degrees. Okay, because again, if they're two same side interior, this angle is the same as this based on alternate interior angles, and then we have a straight line which is 180, so a linear pair. So we combine these two angles, 2x plus 3x is 5x. Combine the constants, 30 minus 20 is 10, equal 180. Subtract 10, 5x is equal to 170. Divide by 5, so so x would be equal to 170 divided by 5 is, so 3 carry 2, 34. So then we're going to find the measure of each angle. So this would be 2 times 34 plus 30. 2 times 34 is 68. 68 plus 30 is 98. And then for this angle, 3x times 34 minus 20. 3 times 34 is, so that's not 102. So times, so that's 12. Okay, yeah, 102 minus 20 is 82. Okay, and 82 plus 90 is 180. So that would be 82. So one of the angle will be 82 and the other angle will be 98 degrees. Okay, and x is 34 degrees. Okay, so let's try the next one, guys. All right, so we're trying to prove the relationship between angles. Okay, so if I'm proving this relationship, it says given AB is parallel, so this means parallel to CD, and transversal EF cuts them at points GH. Prove that the angle at AGH is equivalent to the angle of GHD. So we have a line AB is parallel to the line CD. They're cut by a transversal. Transversal cuts them, so the transversal is EF, cuts them at point G. So this will be point G right here, and point H. Okay, so this is G, and then this is H. So it says we're trying to prove that AGH, so AGH so actually let's make this G. So I should make this G. So GH. So AGH would be this angle right here. Okay, and then GHD. So GHD would be this angle right here, and these are alternate interior angles because it's inside and they're both alternate to one another. So it will use alternate interior angle theorem. Okay, so again, it wouldn't be vertical angles because facing one another is vertical angles. So it would be this angle is vertical. Corresponding angles, alright, so corresponding means that they're in the same position. So like this angle, this angle, this angle, this angle, this angle, this this angle, this angle, this, or rather this angle, this angle, this angle, this angle. Alright, so it wouldn't be corresponding angles, and then supplementary angles equal to 180, so that would be like a linear pair. Okay, so the next one, it says solve the mathematical problem involving isosceles triangle. So in an isosceles triangle, the vertex angle is 40. So vertex where all the angles meet. So the vertex angle, right, would be 40 degrees, and an isosceles has two equal sides. So one side, two sides are the same. All right. So again, isosceles means two sides are equal. Okay. And if two sides are equal for isosceles, that means two angles are equal. So therefore two angles are equal. Okay, so if the vertex is 40 and both these lines are equal, that means both these angles are also equal. So what I would do is that we know that triangle measures 180 degrees, I'm going to take away the angle that we know. We get 140. So that would be what both of these angle measure when you put them together. So I need to know what each angle measures. So I just divide it by 2. So each angle is 70 degrees. Okay. So again, so that was what each of these angles measure. Alright. So now I'm going to go ahead and try to do the next question. So the next question, question 13, it says select the transformation that maintains congruence. Okay, congruence means that it's staying the same. All right. So it says a triangle is rotated 270 degrees clockwise about the origin. Which property remains true? The side lengths change proportionally. So when you're rotating 270 degrees around the origin, that means that you're shifting it 3 quadrants away. All right. So if I'm switching it 3 quadrants away, the only thing that will maintain congruence would be probably, so not the orientation. So orientation means that the way that it's faced. So if we have a figure here, for example here, 270 clockwise, so clock goes this way, 270 will be here. If you're doing some type of rotation, the orientation is going to be different. So the way that it faces is going to be different. So it might actually be faced like, so it might actually be faced like this. So the orientation is going to be different. So this is wrong. The side lengths change proportionally. So no, they won't change, because the only thing that changes the only thing that changes the side length or the distance would be dilation. So no, the side length would not change. The shape changes. No, only dilation changes shape. So the angles are preserved because you're not changing the size. Okay. So then 14 says identify the vertices of a triangle that it undergoes a series of rigid transformations. Alright guys, so for the next one, it says a triangle ABC has vertices, alright, 0, 1 for A, 2, 1 for B, and 1, 3 for C. After a reflection across the y-axis and a translation 3 units down, what is the coordinate of A star, or A double complement, B double complement, C double complement? So we have our coordinates. 0, 1 will be 0 for the x, 1 for the y. 2, 1 will be 2 for the x, 1 for the y. 1, 3 will be 1 for the x, 3 for the y. This is what our triangle will look like. Okay. So this would be 0, 1. This would be 2, 1. Then this would be 1, 3. Okay. So we're reflecting it across the y-axis. So this would be the y-axis right here. So with the y-axis, the x values would be different because you're flipping it to this direction, and then the y values stay the same. So essentially for A, okay, so the first change is that A would go from 0, 1, so it was 0, 1 to begin with. Then B was 2, 1, and then C was 1, 3. So again, the x would change, the y would stay the same. Okay, so we would have 0 because 0 can't change, so 0, 1. Then negative 2, 1. Then negative 1, 3. Okay, so then now we need to do 2 transformations. We're going to do our other 1 transformation, so it's down 3 units. So down 3 units means you're changing the y by subtracting 3. So this would be 0, negative 2. This would be negative 2, negative 2, and then this would be negative 1, 0. Okay, so this would be the new coordinates, okay, for A, B, and C double complement. All right. So let's do the last question. So it says write the converse statement. So it says if 2 lines are perpendicular, then they intersect to form a right triangle. What is the converse? So converse means that you do the not of both of them. So again, it would be not A and not B. So where this is situation A, this is situation B. So it would be not perpendicular and not intersect at a right angle. So this one's wrong because it says right angle. It swapped them. Alright, this one says not perpendicular and not form a right angle. So this one would be the one. So this one. Okay, so again guys, just like that. Oh no, Not is the inverse. I'm tripping. Not is the inverse. I'm tripping, guys. All right, no, this is wrong. It's not not. Not is the inverse. Okay, so converse is swap. So it would be BA. Sorry, it would be BA. So it would be right angle and then perpendicular. So actually, the one that I said was wrong was actually right. Okay, so the answer is A. So the answer is A. That's correct. Okay. So it would be right angle first, so it would be B then A, right angle then perpendicular. So the answer is actually A. Okay.